You ever feel like you're just drowning in coding tutorials? You watch hours and hours of videos, but at the end of the day, you haven't actually built anything. Yeah, you're not alone. So today, we're going to change that. We are breaking down a clear, no-nonsense guide to learning how to code the right way, so you can start making cool stuff and fast. This right here, this is the trap. It's what people call tutorial hell, and so many of us fall right into it. You get stuck just passively watching instead of actively doing. But hey, don't worry, this whole explainer, it's your escape plan.
All right, we're going to tackle this in 4 simple steps. First, we'll get into the right mindset. Then, we'll choose our tools wisely. After that, we'll master the core concepts you actually need. And finally, we'll get to building and accelerating your progress. By the end of this, you'll have a super clear roadmap to become a way more confident coder.
Okay, so before you even write a single line of code, we need to talk about this. This is where most beginners get it totally wrong. They treat coding like they're studying for a French exam, trying to memorize every single word and all the grammar. But the truth? Coding is way more like being a detective. It's all about solving problems. And the code? That's just your magnifying glass.
So look at this. On the left, that's the wrong way. Memorizing syntax, studying like it's a test. That's the stuff that gets you stuck. But on the right, that's where we want to be. Thinking logically, breaking down problems. You're not a memorizer, you're a problem solver. See, the code is just the tool you use to write down your solution. The real skill, the secret sauce, is breaking down a giant challenge into tiny, manageable, logical steps.
All right, now that we've got that problem-solving mindset locked in, it's time to pick our tools. Look, there are a ton of programming languages out there, and trying to learn them all at once, oh man, that is a one-way ticket to frustration. The key here is to focus. Just focus.
So, why are we talking about Python? Well, because it's hands down one of the best languages for beginners, period. The way it's written, the syntax, it's super clean and readable. It's almost like plain English. And what that does is it lets you focus on the logic, on the actual problem solving, instead of getting stuck on a bunch of complicated rules. Plus, you can use it for almost anything, and the community online is just massive. That means you'll never be stuck without help.
Okay, to make any of this learning actually stick, you need a strategy. You can't just say, I'm going to learn to code. No, you got to set a real goal, something you can actually stick to, like maybe an hour a day, and get your tools set up on your own computer, not just some website. And this next one is crucial. When you hit a wall, and trust me, you will hit a wall, just step away. A fresh pair of eyes solves problems way faster. Oh, and one last thing, get in the habit of writing comments in your code. I know, it feels like extra work, but future you will be so thankful you left behind some breadcrumbs.
All right, now we're getting to the real heart of learning smart. It's a concept called the Pareto Principle, but you probably know it as the 80-20 rule. And the idea is simple. You absolutely do not need to know everything to be super effective.
Check this out. It turns out that by really mastering just 20% of the core concepts in a programming language, you'll be able to handle something like 80% of the problems you'll face in the real world. Isn't that wild? So let's stop worrying about the other 80% for now and just focus on that critical 20%.
So what exactly is that critical 20%? Well, it pretty much boils down to these 5 fundamentals right here. We're going to break each one down because honestly, this is where the magic really happens. First up, variables and data types. The easiest way to think about a variable is just as a labeled box. That's it. You give a box a name, say player score, and you put some information inside it, like the number 100. It can hold text, numbers, even simple true or false values.
Next, we've got control flow. You can think of this as the brain of your program. It's how you tell the computer to make decisions with if this, then that statements. Like, if the user's password is correct, then log them in. It also handles repetition with things called loops, so you don't have to write the same code over and over and over again.
Then there are functions. Oh man, functions are all about being efficient. The best analogy is a recipe. You write the instructions for a task just one time, give it a name like calculate score, and then you can use that recipe anytime you need it, anywhere in your code, without rewriting all the steps. It is a massive time saver.
Okay, what about when you need to handle a bunch of information at once? That's where data structures come in. They're just organized ways to store stuff. You have lists, which are kind of like a shopping list where the order matters, and you have dictionaries, where you can look up a piece of information using a unique key, just like a real dictionary.
And finally, we get to the one skill you will use more than literally anything else: debugging. Debugging is just the fancy word for finding and fixing errors in your code. And listen, this isn't something that happens when you do something wrong. It's a constant, totally normal part of the process. It's not a bug, it's a feature of learning.
You think I'm kidding? Get this. On average, developers create about 70 bugs for every 1,000 lines of code. 70. So learning how to hunt down and fix these bugs isn't just a nice-to-have skill. It is the skill that separates people who get frustrated and quit from people who actually become productive coders.
So, how do you deal with errors? First things first, take a breath. An error message is not a personal attack. It's a clue. So read it. Read it carefully. The computer is often trying to tell you exactly what's wrong. Then you play detective. You can add simple print statements to see the values of your variables, or use a tool called a debugger. Once you find the culprit, you make the fix, and then you test it again.
Okay, you've got the problem solver mindset. You know the core concepts. Now for the last and honestly the most exciting part, how to turn all that theory into actual real-world skills.
This right here, this is the whole secret. Knowledge is pretty much useless until you apply it. I mean it. The second you learn a new concept, let's say it's a for loop, don't just nod and take a note. No. Stop the video, open your code editor, and build something with it. Anything, even if it's tiny. That is, without a doubt, the fastest way to make it stick in your brain.
Now, of course, in today's world, we have this ridiculously powerful new tool we can use, AI. But that brings up a really important question, right? How can we use it to speed up our learning without letting it become a crutch that we can't live without?
Look, AI can be an amazing learning partner, but only if you use it the right way. Think of it like your own personal tutor who's available 24/7 and never gets tired of your questions. You can ask it to explain a concept you're stuck on in 5 different ways until it clicks. You can paste in your code and your error message and ask it to help you debug. You can even ask it, hey, create a small coding challenge for me using functions and lists. It's incredible.
But, and this is a huge but, here's the trap you have to avoid at all costs. Do not just copy and paste the code it gives you. The moment you let the AI do the thinking for you, you stop learning. You have to understand the logic behind the code. So remember, AI is a tool to help you think, not a replacement for your thinking. So there you have it. That's the roadmap. We went from mindset to practice, from the core concepts to the smartest tools. The path is totally clear now. You have everything you need to get started on your coding journey the right way. So the only real question left is, what are you going to build first?